Hey, we're ready for a different type of balancing equation. So one of the things you're supposed to know how to do is how to transform word equations into chemical formulas and then balance them. Okay, so a couple of things I just want to review with you. You'll need your periodic table, and you'll need to know your oxidation numbers for these main groups. So these elements have those oxidations, these elements, those oxidations. And remember, these are variable, and we can calculate these using these other oxidation numbers. Okay. The other thing you'll need is your polyatomic ion sheet, and because it does have the names with the formulas with their oxidation numbers. And then, of course, some of the transition metals that we use frequently. I'm not going to make you do the old name. You know, if things were different, you'd have to use the old name in addition. But and some of the things I have may have like the old name. I don't know. I don't think so. So you do need to know some of these main ones that we use. Otherwise, we could just use Roman numerals for any of these others besides the main ones. Something else that's helpful is what's on the back. These are useful formulas and names of commonly used substances all throughout chemistry. Okie dokie. So if you got those things ready, you'll want to stop and pause as I go through. All right, let me see if I can make this a little bigger for you. All right. So, I got to turn this so that it fits my camera angle here. All right, so I can write. So remember, these are the reactants, these are the products. We need to convert these to chemical formulas and then use coefficients to balance. So you use subscripts to balance the oxidation numbers. So the oxidation numbers are the superscript number, the plus or minus, and that's because they have either gained or lost electrons and become either positive because they have more protons and electrons, or they become negative because they have more electrons than protons. Okay? So I know that copper is Cu, so the first thing you do is you just write a skeleton equation. The Roman numeral tells me the oxidation number, so I know this is a +1. So I know this is Ag. And I know, according to my polyatomic ion sheet, nitrate is -1. And remember, the sum of the oxidation numbers have to equal 0 because they're neutral compounds. So I just need to write the polyatomic ion formula for nitrate, excuse me, silver 1 nitrate. Okay. And then silver, and we're going to do the same thing with copper 1 nitrate. I know that this is +1 because the Roman numeral tells me so. And we just wrote the nitrate and looked at my sheet, and I'm not going to pull up the sheet every time I do these because it takes too much time. But you can look at your sheet and see that. So these equal, so I don't need to introduce any copper. I don't need to introduce any subscripts to balance this. Okay. Now, once we have the formulas written, now we can go through and count our atoms and then use coefficients to balance. So I see I have 1 copper, that's balanced. I see I have 1 silver, that's balanced. The nitrate didn't break up. Instead, it's here in both places, and we can count that as one thing, and we don't have to count nitrogens and oxygens separately. Now, in some cases, some of these bonds break and make different substances. Okay, in this case, they stayed together. So, and this is 1 nitrate, and there's no coefficients that we need to write, and it's balanced. So, if you were doing this, you know, you'd put a 1 like on a Schoology assessment or maybe on a test or something like that as a benchmark test. Okay, let's look at the next example. We've got fluorine reacting with sodium bromide to produce bromine and sodium fluoride. All right, so this is a element by itself, and one of the things you'll have to remember, I should have done this earlier, is you need to know your 7 diatomics. and hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So, and those are just the names of those compounds. Always occur as two things together. So one of the things you need to notice with the ending, remember the ending when we did nomenclature, the ending tells us what kind of bond it is, and the fact that this is IDE as opposed to INE tells me that it's either gained or lost or sharing electrons and it formed a bond. Okay, so the fact that this is just fluorine means that it's F2. And then this is a ionic compound consisting of a metal and a nonmetal. Sodium is in group 1, bromine is in group 17, so those cancel and we don't need to use any subscripts to balance. And then ene, bromine, so we're going to have to write that as a diatomic. And then here's an ionic compound consisting of group 1, group 17 nonmetal, sodium fluoride, group 1, group 17, and I don't need any subscripts for that one either because they cancel. All right, so I have 2 fluorines, 1 fluorine, so that's not balanced. I have 1 sodium, that is balanced. I have 1 bromine and 2, and that's not balanced. So in order to balance my fluorines, I can put a coefficient of 2 here, and then that increases my sodiums. So I'm going to need to increase the sodiums, which also balances the bromines, and now we have a balanced chemical equation. Ta-da! All right, let's go to the next one. So we have iron reacts with copper 2 sulfate to produce copper and iron 2 sulfate. So iron by itself, copper 2 plus 2, sulfate minus 2. And then we have copper by itself, produces iron 2 sulfate. So I don't need any subscripts for that one either. All right, and then we take a look and we got 1 iron, that's balanced. 1 copper, 1 copper, 1 sulfate, and we don't need any subscripts. I mean coefficients, excuse me. Okay. All right, we've got magnesium reacts with aluminum chloride to produce aluminum and magnesium chloride. So we've got magnesium. Aluminum is in group 13, so it is a +3. Chloride, and ionic compounds, so we're going to have to charge balance here with subscripts. Chloride in group 17, so those don't equal. So I know in order to make this a balanced equation, formula, I'm going to need to introduce a 3 here. Okay, so aluminum chloride reacts to produce aluminum and magnesium chloride. Okay, it's not balanced. I need them to balance, so I'm going to have to introduce a subscript of 2. All right, now that we have our skeleton equation, we're going to need to mass balance using coefficients. So I see I have 1 magnesium, those are balanced. I have, oh, sorry, too bad y'all can't say, hey, you wrote that wrong. Okay, I have 1 aluminums on either side, but my chlorines are not balanced. Okay, so I know I can put coefficients in front of here to balance those, which are going to unbalance my magnesiums and aluminums. Well, I can't do anything to make that 2, and I can't do anything to make that 3, but 2 and 3 are factors of 6. Okay, now I have unbalanced magnesiums and unbalanced aluminums, but my chlorines are balanced because 2 times 3 is 6 and 3 times 2 is 6. So I'm going to need a coefficient of 3 here and a coefficient of 2 here, and now we have a balanced equation. All right. Let's look at number 5. I have potassium reacts with zinc 2 chloride to produce zinc and potassium chloride. All right. A lot of times we don't write the Roman numerals for some of the transitions that are fixed in their oxidation numbers, and like those of group 3 and like group 12, they tend to have only one oxidation state. But being a high school student, I think it's easier if I go ahead and write the Roman numeral for you. So you will sometimes see this as written just as zinc chloride. Okay? All right, we've got potassium. And then Roman numeral tells us the oxidation. This is in group 17. That's not charged balance, so I'm going to have to use subscripts to balance. So 2 times 1 is 2, and 2 times 1 is 2, so 2 minus 2 equals 0. And then we end up with zinc. And this is group 1, group 17, potassium chloride. Now we got that. We need to balance. So those are, potassiums are equal, zincs are equal, chlorines are not equal. So I'm going to have to do something to bring that up to 2. And since I had to do that, I'm going to have to make that a 2. And now we have a balanced equation. How are we doing? Hopefully okay. All right, let's look at this one. We got calcium hydroxide reacts with hydrochloric acid to make calcium chloride and water. So this is a group 2 metal with a polyatomic ion. So I'm going to need parentheses, polyatomic ion, since I need 2 of those for every one of those to make it balanced. So if you'll remember your acid nomenclature, hydrochloric, hydrostemic acid, this is a binary acid of a halogen, so it's just HCl. You have to also charge balance your acids. So I know hydrogen's +1 and chlorine's -1, so that I don't need any subscripts. So acids act just like ionics, even though these are covalents. You'll see and later when we talk about acids and bases, these also ionize just like ionic compounds do. Okay, so we've got calcium chloride, so we're going to need a subscript there to make that balanced. And we all know what dihydrogen monoxide is. It's a very dangerous chemical. Many people die from this every year. All right, this is an acid-base reaction, neutralization reaction between a strong acid, strong acid, excuse me, making a salt and water. So we need to look at our formulas here. We've got 1 calcium, 1 calcium. See how this hydroxide's broken up? We don't see it over here. So we have 2 plus 1 is 3 hydrogens and 2 oxygens. So I have 2 hydrogens and 1 oxygen. And then over here I have 1 chlorine and 2 chlorines. So I could put a 2, start off by putting a 2 here to balance my chlorines. And now I have to recount. I do have 2 plus 2 hydrogens is 4 and 2 oxygens. So I can see I need a 2 here to make a balanced equation. Alrighty. Alright, last one for today. Alright, so we have sodium hydroxide reacts with copper 2 chloride to produce sodium chloride and copper 2 hydroxide. Let me make this a little bigger for you. Okay. So this is again a group 1 metal polyatomic. It's ionic. Hydroxide is -1. So I don't need any subscripts to charge balance that. Copper 2, we know the oxidation number, chloride group 17. So I do need subscripts to balance that one. And then we've got sodium chloride. Okay. So we just, good old salt. And then copper 2 hydroxide. So we're going to need subscripts to balance that. All right, we're lucky in that we've got the hydroxides stay together, so that's a little less keeping track of. 1 sodium, check. 1 hydroxide, 2 hydroxides, not balanced. 1 copper, correct. But 2 chlorines and 1 chlorine. So since I need 2 hydroxides, I'll put a 2 over here, and then that will increase my sodiums, which will help balance my chlorine, so now we have a balanced equation. Okie dokie. So that's all, folks. Yay!